All right, so we proceed. So I said we are going to look at the equality of sets. Yeah, so we are going to look at the equality of sets. So how do you know that these two sets are equal? How do you know that these two sets are equal, and how do you know that these two sets are equivalent? So two sets are said to be equal if and only if they have the same number of elements and they have exactly the same elements. So two sets are known to be equal if they have the same number of elements and they have the same elements. Okay, so I'm trying to look at in the group, there's someone who's saying they can't get me clear. So we proceed. So I was saying, if let's say set A is equal to set B, it means that A, okay, let me start this by listing the sets. So if let's say you have set A being equal to, you have A, B, C. Then you also have set B being equal to A, B, and C. So since set A and set B have the same number of elements and they also have exactly the same elements, we can say that A is equal to what? Is equal to B. But if you have set A being A, B, C, and then B is equal to 1, 2, 3. So set A is not equal to set B because they may have the same number of elements, but the elements that are in set A are totally different from the elements that are in set B. All right, so I'm trying to solve an issue in the group. There's one who's unable to get us. Yeah, but we'll be doing that, but I'll manage. I'm sure he's even okay. Right now, I'm sure he will start hearing. Okay, so we're talking about the equivalent sets and equal sets. So I was saying for set A to be exactly or to be equal to set B, the elements in set A and the elements in set B are supposed to be the same, and they are supposed to be, the number of elements are supposed to be equal. But if the number of elements is the same and the sets are what? Are different, it means that the two sets are what? Are equivalent. So two sets are known to be equivalent when they have the same number of elements. So they may have different elements, like what we have in set A, we have letters of the alphabet, and then in set B, we have numbers. But since they have the same number of elements, here we have 3 elements, even there we have 3 elements. Since they have the same number of elements, we say set A and set B are what? Are equivalent. But for two sets to be equal, they are supposed to contain the same elements and the same number of elements. Yeah, so this is a straightforward thing. So let's look at the definitions here. So two sets A and B can be equal only if each element of set A is also the element in set B. Also, if two sets are the subset of each other, yeah, so if two sets are the subset of each other, they are said to be equal. So this is represented by A is equal to B. Yeah, so when A is equal to B, it means that A is a subset of B and B is also a subset of A, which means A is equal to B. Yeah, so if the condition discussed above is not met, then the sets are said to be unequal. This is represented by B, A is not equal to B. Okay, I'm trying to look at what is in the group. Okay, so when we look at the equivalent of sets or the equivalence of sets, I talked about the number of elements in the sets. So when the number of elements in set A are equal to, is equal to the number of elements in set B, we say the elements, rather the sets are what? Are equivalent. Yeah, so they may have different elements, but as long as the number of elements is the same, then the two sets are equivalent. Okay, so I'll also make sure that I forward this slide to the group so that you can use it for studying. All right, so this is how you show the number of elements. Yeah, so this small letter N, in some books, they will not say a number of elements. Some books, they will use the word cardinality. It's just the same. All right, so let's look at discrete and continuous sets. So when we talk about discrete sets, these are sets that can be represented using these kinds of brackets. They are called parentheses. So discrete sets are the sets that we normally use, the sets that most of the people know. When we say A is equal to A, B, C, so this set is known as a discrete set because we can list it using the parentheses, these kinds of brackets. Yeah, so any set that can't be listed using these brackets is called a continuous set. Yeah, so sets in which it is impossible to list are called continuous sets. So a set, I think on the, I said any set that you can't list with these brackets, they are called continuous sets. No, any set that you can't manage to list, yeah, let me leave it there. Any set that you can't manage to list, then it's called a continuous set. The reason why I've disqualified the first statement, which I said, is because a continuous set can also be written using these kinds of brackets. Yeah, so these are just brackets. So a discrete set can be listed, and then a continuous set can't be what? Can't be listed, in short. So examples, set A contains elements 1, 2, 3. You can list this set. Or let me write maybe in set with annotation. You can have set A is equal to X is such that X is a member of what? Natural numbers where X is between what? 0 and where X is between 0 and 5. So we can list this set because natural numbers are simply just counting numbers starting from 1. So counting numbers starting from 1 are called natural numbers. Okay. So this is, yeah, so we can list this set. So this set can be listed. This is going to be 1, 2, 3, 4. We're going to end there. So these are natural numbers between 0 and 5. So this is called a discrete set because we are able to list the elements. But if we say, let's say set B is equal to open brackets, and then we have maybe 2, 5. So we can't manage to list this set because when we use these kinds of brackets, it means that we are talking about real numbers. And the set of real numbers is simply just a number, rather a set that contains rational and irrational numbers, which I believe we're going to discuss in the next chapter. Not really a chapter, but in the next, I think in the next session that we're going to have. We're going to discuss what rational numbers and what irrational numbers are. So when you add the two sets, you come up with a set that is known as the set of real numbers. So set of real numbers is simply just a mixture of what, or rather, it's simply just the addition of rational and irrational numbers. So rational numbers are those numbers that can be expressed in a fraction form, and then irrational numbers are those numbers that cannot be expressed in a fraction form. Numbers like pi, yeah, so such numbers, or the square root of 2, these are called irrational numbers. So we are going to see how you can prove that the root of 2 is an irrational number in the next session that we're going to have. Okay, so when we talk about this set, we're simply talking about numbers, the decimal numbers that are between, I mean, not only decimal numbers, but all the numbers excluding excluding complex numbers or imaginary numbers, all the numbers between 2 and 5. So between 2 and 5, we also have 2.000000001. We also have 2.0000000. You write a lot of zeros and then you put a 1 at the end. So you have those kinds of numbers. So you can't manage to count such numbers between 2 and 5. This is the reason why we consider this set to be what? A continuous set. So sometimes it may not be called a continuous set. They'll call it a what? An infinite set. All right. So let's continue. So these are some of the examples that I gave. These are some of the examples. Yeah. So these are the examples. So you can see that the first set there is a continuous set. This one here, let me be. So this one is a continuous set because we can't list the number of elements in this set. Even this one is a continuous set because we can't list the numbers that are in this set. And then the remaining sets that we have, that we are used to, are mostly what? Discrete sets. Sets that we normally use, or rather the sets that we normally use these brackets to list. We have these questions there, which are very simple. The question is asking us to express what we have there in a set builder notation. So these are very simple and straightforward questions. So it's just a matter of writing. You say A. So this is the simplest way you can do set builder notation. You have A is equal to, have X is such that X is a member of these are what? Okay, I think for this one, since we don't have anything, if you can manage, you can define a function that is going to output these numbers that are in brackets there. But the shortest way to do this without stressing, you just say X is such that X is what? Is equal to 1, 2, 3, 8. So this is the shortest way you can do set builder notation. It's very simple. And so I've put the solutions for these questions in the slide. I'm going to send the slide. Yeah, so remember what I was saying? I was giving you examples to say when we talk about numbers, when you have 0.2 in brackets like this, or brackets with or square brackets like this, it means that we're talking about numbers between what? 0 and 2. This is the reason why they are using the less than symbol here. It means that we're talking about numbers between 0 and 2. Here we're talking about numbers from 0 and between, between 0 and 2, and 0 is part of the set because we have less or equal to there. Then 2 is not part of this set because we only have less than there. Yeah, so here we're talking about numbers between 0 and 2, and 2 is also part of what? Part of the set because we have less or equal to symbol there. Then there, 0 is not part of the set because we have a less than symbol. So I can also teach you set builder notation just in a few seconds here. It's simple. Sorry, not set builder notation, set intervals. So whenever you see this kind of a bracket, it means that the number which is there is not part of the set. And then when you see this bracket, the square bracket, it means that 3 is part of the set. So if I say 2,5 means that 2 and 5 are not part of the set. We're just talking about numbers between 2 and 5. And if we say 2,5, it means that 2 is part of the set because of the kind of bracket which is there, but 5 is not part of the set. And then if we say 2,3, and then we do this, it means that 2 is not part of the set, but 3 is part of the set. And the other thing you have to know is that whenever you have an infinite symbol, you always have to represent it with an open bracket. So this one is known as an open bracket, and then this one is called the closed bracket. So this part, despite it being this side, it will also be called the closed bracket. Then this one is an open bracket. Yeah, and then whenever you're dealing with an infinite symbol, there's always supposed to be an open bracket there. Whenever you're dealing with an infinite, so this one is a negative infinity. So even when it's positive infinity, you have it this side. It's also supposed to carry an open bracket like that. That's what these brackets mean. So when it's like this, it shows that the number which is there is not part of the set. Then when it is a square bracket, it means that the number which is there is part of the set. All right, so subsets are simple. Yeah, so a set A is a subset of another set B if all the elements of set A are the elements of the set B. In other words, the set A is contained inside set B. The subset relationship is denoted as A subset of B. So what they mean is that for set A to be a subset of B, for set A to be a subset of B, it means that all the elements that are in set A, they are also part of set B. What this means is if you have set A as 1, 2, and then you have 5, then you have set B being equal to 1, 2, 3, 4, 5, 6. So as long as this set, all the elements that are in this set are also present in set B, we say set A is a subset of set B. Because we have 1 there, we have 1 there, we have 2 there, we have 2 there, we have 5 there. So set A is a subset of set B. Because all the elements that are in A are present in B. Yeah, so these are some of the examples. You can take time to look at them when I send the slides to the group. So a Venn diagram, I'm sure most of us know it. This is a box that we all know. with E there. Then here you can have 2, 3, or more sets. You can have even more than 3, depending with how you want to draw it. So these are the sets. So this is how you draw the Venn diagram. And then here you have elements. So that is the Venn diagram. So whatever that you have in between here, where 2 circles are, I don't know what you can say, but they are meeting, where they have this part here. This is where you find the intersection. Yeah. This is the intersection, meaning the elements that are in between there are common. They are found in both sets A and B. What is the union set? So the union set is simply just a combination of 2 sets. If, for instance, you have set A, if you have set A being equal to A, B, C, and then set B is equal to A, C, D, E. So when you combine these 2 sets, you add them. So the addition of 2 sets is called what? Union. So A union B is equal to, you write your A there. So if the letter is appearing 2 times in the sets, you just write it once, and then you have B there, you write your B, you have C there, you write your C, you have D there, you write D, and you also have E, you write E. So this is our A union B. So A union B, or the union set, is simply just the combination of 2 sets, the addition of 2 sets. Intersection set is simply just finding the common elements between 2 sets. You can have set A being equal to A, B, C. And then you have set B being equal to A, B, D, E, F. So A intersection B is simply just the elements that are common. You just check and get the elements that are the same in these 2 sets. So we have A there. So you write your A. You have B there. You write your B there. So this is the intersection, because these are the only 2 elements that are present in both sets. So this is an example. This is an illustration of the intersection and the union set. So this one is A union B. This one is A intersection B, according to the Venn diagrams. What is a complement of a set? So when we say a complement, when we say A complement given the universal set E, it means that when you say A complement given the universal set E, it means that you're going to list all the elements that are not in A, but they are present in the universal set. What that means is that if you have, let's say the universal set is 1, 2, 3, 4, 5, and then you have set A, then you have set A being equal to 1, 2, 3. If we say, okay, yeah, if we say A complement is simply just a list of the elements that are not in A, but they are present in the universal set. So in A, we have 1, 2, 3. So the elements that are not in A, but they are present in the universal set are what? Are 4 and 5. Yeah, so representing A complement in the Venn diagram, A complement can be represented like this. So you have your universal set there, then you have your A there. So A complement is simply just what is outside A, but it's present in the universal set. So I'll forward the slide for the sake of revision. The set difference. Yeah, so the set difference, you can have, sometimes I'm sure you've seen in some books, you see something like A minus B. What does this mean? This simply means that you are just finding A intersection B complement. So instead of writing A minus B, you can also write A intersection B complement. It's still the same. You still get the same answer. So what this means is that you have to write the elements that are in the elements that are in B, the elements that are in A excluding those that are in B. That's what it means. Or you simply just use this format here, which is A intersection B complement. So you're going to see how we're going to solve this using examples. That is in the next session that we're going to have. I'll prepare a lot of examples on what we have learned tonight. So the set difference is simply just this one. So A minus B means that we're listing the elements that are in A, excluding those that are where? In B. All right, so that is it. Thank you for watching tonight's lesson. So this is the end of our lesson tonight. So the next time we're going to meet, I'll prepare examples that we're going to go through together. The examples will be from the handout and the assignment. If there are questions on sets in the assignment, we have to discuss that. We know how to solve and how they bring questions. All right, thank you very much. See you in the next session. Shalom, shalom.
Hello there.
Okay.
Yeah. Before we go, I think the most thing when we send the module,
okay,
I think you use those unsolved activities on the module. I'm sure those are the ones where the questions will be coming from during the exam. I'm sure.
Yes, that's what I actually do in most cases.
All right, thank you.